Hey everyone, welcome back. Today we are going to discuss about what is a microservice. Already we started our microservices architecture, but you should have a knowledge on what is a monolithic and what is a microservice architecture. What is the difference between two? Just let me discuss about intro about, then we'll start our development as well, guys. Okay. Before going to start, anyone has any questions? Are we good so far? You can talk to me, guys. Okay.
Hello. Sir,
Yes.
what is the difference between embedded and embeddable? That annotation we use in data Spring JP.
That is about a composite primary key purpose. We will use that annotation.
Okay.
When you want to create composite key, more than one key, then you should use embeddable and embeddable ID for that. Okay.
Yes.
Yeah, sure. Thank you. Okay, so we'll start about what is a microservice. A lot of people are thinking like it is separate technology. Okay, it is kind of a different apart from Spring Boot. Lot of people think in this approach who are completely new for microservices, guys. Basically, microservice is not a technology, not a framework, not an API. It is one of the design pattern. What kind of pattern? Architectural design pattern. What is a microservice means? The way of writing the code, just we are dividing one pattern by following one pattern, that is architectural design pattern. Why microservices came to the market means to avoid the problems of monolithic architecture. How our monolithic architecture will look like, how we can divide our architecture into microservices. I am going to discuss in detail level discussion, guys. This microservice not only specific to Java, it is a universal design pattern. Anybody can follow this pattern here. Okay. Now just I'm going to display one diagram. Have a look here. Suppose the you need to understand main thing about difference between monolithic versus microservices here means, suppose in monolithic architecture, whenever you are developing any project, okay, we have only one project here, means there is only one database. Maximum we can connect to only one database. Your application code will be available and you have a front end application will be there. Means till now we created two projects, user service, product service here. So user functionalities, product functionalities, I want to keep it into a single project, and that single project I want to communicate to database. This kind of architecture we can call as a monolithic architecture. Means like user functionalities, product functionalities, order functionalities, every all the controllers you created in a single project, and that project is talking to single database. That architecture we can call as a monolithic architecture here. The same architecture we can divide into microservices. Means just one microservice can communicate to one database. User, this is a user functionalities. This is called product functionalities, cart functionalities, payment, order. You can create n number of Spring Boot projects. Each project can communicate to own database. It can be same database, it can be different database also here. If it is a 100% pure microservice architecture means every microservice their own database here. Even though we are using MySQL as a database, we are creating multiple schemas. Each user has a user DB, product DB, like you can take like a real time, it can be a MySQL, it can be a Oracle, it can be different number of MySQL instances also here. It can be any database. One microservice can talk to Mongo database. One microservice can talk to different database. Here, databases are independent. There is no communication here. If you see now here, this is different database. When you have a different databases, now how this communication will be happen, what are the challenges we have in microservice architecture? We should follow single responsibility principle. Each microservice has one functionality. Only user functionality means user specific operation should be there. Inside a user microservice, I should not perform like a search operation, product operation, payment operation. No, we should divide our requirements into multiple microservices here, like based on domain knowledge, it will be divide your architecture. But even though backend has number of services, but we have a single interface like a through react.js or through angular.js, just you can use this application. So if you see here, if you take a monolithic architecture, if you take a small bank application, just these diagrams I got it from the Google. For your explanation, I'm explaining to you guys. So if you take one bank application, inside a bank application, I have a loans functionality, cards functionality, accounts functionality. All the functionalities are available into single GitHub repo, and it has a single CI pipeline, CI CD pipeline, Jenkins, only one job. And this whole application, we have a user interface, your business logic, and your database logic. The outcome from monolithic application is a WAR file, web archive file, or enterprise archive file. You got some WAR file. That particular WAR file we need to deploy into a Tomcat server or WebSphere or WebLogic. It can be a web server, it can be a application server. In a server, we need to deploy the WAR file, and it has a single database here. This is monolithic architecture here. This is a monolithic architecture here. What are the problems we have when you have a difference? Means the same application, if you divide into microservices architecture, simply like accounts, here if you see loans controller, cards controller, and accounts controller, all controllers are available in a single project, that is monolithic application. Now you need to divide, each controller has a separate project. Obviously it will become microservice architecture. Now accounts has a accounts repository, loans has a loans repository, cards has a cards repository. Every repository means one scrum team. In the real time we are working in organization means this is completely work by one scrum team here, and this is another scrum team, this is another scrum team. One scrum team is around 6 to 7 members, it will be there. One tester, two developers, one architect or some QA, like it will be divided. One scrum master. Now it has a separate Jenkins pipeline, and it has a separate database here. Now it is completely taken care by few developers, and this job few developers, and this job few developers. Around, when you divide your application into microservices, infrastructure, it will be over, headache will be there, lot of challenges we have. If you have architecture in this way, there is no much challenges, but we have a disadvantages we have compared to microservice architecture. Like Here, if you see here, six developers, 60 around 18 employees we have. But here, if you take all employees are working on a single project only here. But here it has a separate scrum teams will be there. So account has a account APS, loans APS, and cards APS. All the APS we need to integrate in the front end. That is through your e-commerce application. In the back end, you may have n number of microservices you may have, but in the front end, all the APIs I should be invoke here. Then what's the difference between these two architecture means, coming to monolithic, it will be built on a large system here. Now here every service has a small independent module. That is the first difference. Second, it is not easy to scale based on the demand. Means if you take a single project, inside a single project you have a search controller and payment controller, order controller, shipping control. All the controllers are available in a single project. But in Flipkart, in Amazon, in big billion day, more users are involved. Millions of users are accessing your application. Now, in those use cases, especially for search only, I need to run I want to run multiple instances for your application in this way. In monolithic, that is not possible. A complete project I need to scale. But whereas in microservice architecture, search functionality will be available here, order functionality is available here, payment functionality is available here. Now, here, search I can run on multiple number of instances, replica sets. More users are involved means more servers I need to create to handle the traffic. So that's why it is easy to scale based on the demand, based on the traffic we can increase or we can decrease. In monolithic architecture, it is a shared database. That means single database for all the functionalities. But here each project and module their own database here. For example, if you take MySQL as a single database, but I am creating multiple schemas. In that approach, you can feel it kind of a microservice architectural style. But in single schema, all tables will be there in monolithic. But if you are in a microservice architecture, every schema has their own database here. Okay, and a large code base makes IDE become slow. It is a small difference. Each project is independent, it will be small in size. Now, whenever you want to deploy your monolithic application, continuous deployment becomes difficult. If it is a monolithic architecture, maybe 3 months once you can deploy, or 6 months once you need to deploy your application. But in the microservices, every month you can do the releases here. With respect to another project, you can independently deploy your functionality here. Here, if you make complete functionality in the monolithic style, future you want to change some technology, it will be very, very difficult here. And understanding the functionality is also difficult for developers. Even if you want to do some bug fix, you need to thoroughly understand and change the code, and you need to deploy. It will affect lot of places. In monolithic architecture, everything is tightly coupled here. But in microservices, you can change your technology, like search I can develop using Node.js, or the order functionality I can develop using Java, payment functionality I can develop using PHP. Easily you can change your technology. Every microservice or every project is independent here. When you divide your application into microservice architectural style, we have a benefits and we have a challenges. Disadvantage, not a disadvantages. We have lot of challenges we have in the real world use case here. What kind of challenges we have? First, benefits, if you see, independent deployment, scalability of individual components means you can create multiple replica sets for your application. And fault isolation means if any microservice is down, how to handle. Technology diversity, you can change the technology and faster development and time to the market. Easily we can create our application very fast. But coming to challenges means distributed system complexity. When you are dividing single project into multiple granular level projects, okay, managing communication, lot of challenges we have. And the data consistency issues also we have. Data we should store properly in every database. Why? Because there is no relationship concepts like one to one, one to many, many to one. Like if you have a single project, you can make those kind of changes. But when you divide into microservice, every database has a different. Those kind of mappings also may not be there based on the requirement. Service communication. Again, the service communication can be synchronous and asynchronous, like a event based communication and through when you have a user service, you have here you have a product microservice. Now you have a cart microservice. Now cart microservice is depending on the user and it is depending on the product also. This kind of inter-service communication, one of the challenge also we have. And operational overhead, CI/CD means more number of services, more number of Jenkins jobs you need to create, CI/CD pipelines. And testing and debugging. If you have some issue in one service, you need to understand complete flow as well here. Those are all kind of a different challenges. We have other challenges also we have. These are the main challenges whatever we have in microservice architectural style. In the real world use cases, if you take Amazon, hundreds of services, Netflix, Uber, they can go number of microservices they can create as well. It's not like a 20 members or 30 members are working on to develop our Amazon application. No, number of services will be there. Lot of employees are working on a single project here. Okay, those kind of a real world use cases. Even we are developing our e-commerce application with limited functionality, not complete functionality. If you do complete functionality by 6 months or 1 year also we can develop also here. But as part of our training, the main intention is how architecture will be look like, what kind of skills you need to learn, what you need to develop for deployment level, business logics level, completely business logics, guys. If you know business logic, it's kind of one microservice. Apart from business logic, okay, we need to understand about challenges. How these challenges we can overcome in microservices architectural style here. If you take our tech stack, okay, now we are using Spring Boot as a project and container for deployment level. We are using Docker and Kubernetes and CI/CD pipeline. We are using Jenkins and one more thing to monitoring your microservices. We are using Prometheus and Grafana and communication. between our services, we are using REST template, we are using Fiend client, and we are using Apache Kafka event driven communication. And databases, we are using MySQL and Mongo database also here. These two databases I am using as part of our development here. Now, by using these technologies, slowly we are developing our microservices here. Without having you knowledge what is a microservice, we already started two microservices, one for the user microservice, another for the product microservice here. See, one microservice is nothing but REST APIs. Just instead of single project, I divided into two projects. That's it. If you know REST API, microservices development is dead easy for you here, guys. Now, our architecture, what we are discussing, e-commerce application. In e-commerce application, what you will do as a user point of view, user can buy the product, sell the product, or he can do everything in the online user functionality like Flipkart or Amazon. What kind of modules are available? Typically, if you take the architecture, have a look here. If you take a typical workflow as a user point of view, what you will do, or admin point of view, what you will do, what are the responsibilities in the e-commerce application. If you take a user, now you want to purchase a product. Now if you want to purchase a product, what you will do, first you should do registration and login. This is the first functionality you should have. Without the first functionality, you cannot purchase the product. Second, you products should be available for you. As a user point of view, you can search the products, that's it. But admin point of view, to display the products, a vendor needs to create the product. That is about product functionalities here. If you have a product, now what will be the next functionality? You need to add to the cart. Add to the cart or update the quantities. You can remove the quantities, like lot of functionalities you can develop also. That is about the cart functionality here. Once you have a product, you need to place an order. Now that is called order checkout. Once you place an order, now you need to communicate to the payment gateway. Now in the real time, we have a Razro Pay payment gateway, like number of gateways also there. Now usually that is for the payment. But we are learning on the back end, just kind of a dummy payment controller will create and will show you that activity. Who are already taken our React.js course, you can able to see real-time payment gateway in the front end, in the back end. You will understand that flow in the front end course here. And delivery, like a shipping. Once your order is placed, how you can handle the delivery items, like you want to ship the order, you want to deliver, and you want to place an order. When you want to perform these six steps, now this is our architecture will look like it contain lot of other things as well. Some kind of design patterns will come to the picture here. When service is down, what kind of pattern you will use. Now front end, we have a API gateway, I want to provide a security, like number of things are involved in this architecture here. Now in this architecture, what functionalities we completed, can you tell me, guys? What functionalities we completed till here? Tell me, guys. No, no one.
User service and product service we
Exactly. User has a user database. Separate database is same, but schemas are different. Now here I am using JE user DB. Now this is JE product DB. Now user functionalities means, like you can create a user, you can get the user information, and alternatively you can do updating the user, deleting all the APIs you can develop. Typically, Every microservice you should perform our CRUD operations like payment MS, order MS, shipping MS, and here some event communication we have. Here Mongo database also we have. Here Apache Kafka also we have. Every microservice generating the logs for our application. Those logs, everything will be stored into ELK stack, centralized logging, where you can verify if any issue happen. You can verify in this ELK stack as well, Elasticsearch, Logstash, and Kibana dashboard. And through monitoring, now you may have hundreds of services at one place. I can monitor my services are running or not, and we have a Eureka server to monitor, and communication is easy if we are using Eureka with fin client communication, inter service communication. Here all the services, we should be dockerized our application. Then I can deploy into our Kubernetes cluster. This is the end goal of this architecture and deployment level also here. Clear? This architecture, how it will be look like step by step. When I start about cart ms, what kind of functionalities are required? If you take cart ms, today we supposed to start cart ms. What cart ms? If you want to add a product to the cart. Now, cart MS is depending on product MS. And who can add the product? User. So, cart can communicate to user MS, and a cart can communicate to product MS. And while doing communication, I should store my data into cart database, your information here. Once you are done about cart MS, then you can place an order. Now order MS can communicate to user, can communicate to product, and can communicate to the cart. But here cart is already communicated to user and product. Now from order, I can communicate to the cart MS and I can do some operations. In this way, communications will be there, inter service communication also here. Are you clear what is a microservice architecture?
Yes, sir.
Yes.
It's clear.
Everyone good?
Yes.
Super.
Yeah, I got one doubt.
Yeah, go ahead.
You are saying like that before we are using monolithic architecture, right?
Correct.
And then now we are using microservice architecture. Is
Mm.
there any possibility it's migrate to monolithic architecture to microservice
Yes.
architecture?
Yeah.
What they
Nowadays
think?
people doing that. That also doing through one pattern, strangler design pattern. Using that pattern, they will be divide our monolithic to microservice architecture. It is not like a simple straightforward, I want to divide immediately. Not at all impossible. Step by
Okay.
step. That is one kind of a pattern. That is some kind of a theory only. As part of my interview guide, already added those are all the questions. Don't worry.
Yeah. Okay. So thank you.
Okay. Yeah. That is one of the top interview question as well. Okay.
Yeah. Thank you.
Sure. Now, so to these challenges, to get a solution, the Spring team divided one kind of a libraries they given called Spring Cloud libraries they given. Using these libraries, we can achieve some problems in our microservice architecture. Like whatever problems we have, the challenges of microservices solution given by our Spring Cloud team. So these Spring Cloud is given lot of tools they given to us to utilize in our application here. Like this, it will be helpful for our developers when you are creating microservice systems here, like a number of services here. Why basically we need means it will be solved like a common microservice problems, and it helps build the systems that are resilient, scalable, and cloud ready. This architecture I want to deploy into our cloud environment also here. It should be support. So it will be easily integrate these Spring Cloud with our Spring Boot also. And as well, this architecture can works with our Kubernetes, AWS, Azure, in all the environments also. We can deploy. Now the popular deployment tool supporting with our application architecture now with Kubernetes here. Deployment purpose orchestration engine, that is about our main Kubernetes here. And by following this activity, the Spring Cloud is given couple of features for us like service discovery, centralized configuration, load balancing, API gateway, circuit breaker, distributed tracing, cloud messaging, number of features they given by the Spring Cloud here. Out of that, we will be integrate couple of things in our architecture also here. The first one what we are going to discuss about service discovery mechanism here, like example like a Eureka server here. We will be slowly discussing like a API gateway, Spring Cloud gateway, circuit breaker, resiliency 4J, distributed tracing like a Spring. Now this is deprecated. We have a micrometer and cloud messaging, Apache Kafka, like couple of design patterns we will be discuss as part of even our project also here, guys. The popular one right now, I mean to say, still using here. So out of these few projects, most of the projects given by the Netflix. I hope everyone know the Netflix given few libraries also to develop these kind of technologies as well. Now I have one diagram. Let me show you. Yeah, if you see first feature called service discovery. Service discovery means Netflix given, and previously we are completely depending on the Netflix team. Later on time, Spring team introduced their own libraries instead of depending on Netflix here. So Netflix for service discovery purpose, they given Eureka server and Eureka client. Now, Spring Cloud alternatively, they are not yet given. Still, we are using actively, we are using here. Few organizations may use, may not use also here. And load balancing. Previously, we have a Netflix is given like a ribbon as a library. Now we are not using, completely deprecated internal mechanism we have called Spring Cloud Load Balancer, mainly for client side load balancing here. Anyway, we'll be discuss points later on time. Now, declarative REST client to communicate between couple of services we are using called Fiend client is nothing but open Fiend here. Still, it is a supported same library we have OpenFin. Now, communication between our services, we are using OpenFin here. We have in monolithic or in microservices, still we are using REST template also for communication. Both I will explain also here. Coming to circuit breaker means whenever service is down, I want to use this pattern. Like previously we have a Hitrix. Later on time, the new part called resiliency 4J. This is actively using green color, whatever you shown, this is actively using right now. And a gateway. Now this is called cloud libraries. Previously we have a Joule, now Spring team given called Spring Cloud Gateway. Now this is also we are using. And distributed tracing, Netflix is not given anything. We have a Spring Cloud Sleuth and Jipkin. Jipkin also in the real time we will never use, and this is replaced by micrometer tracing here. Let me change it now itself, just a minute. Micrometer tracing, just I am updating here, guys. This is the one we are using in the real time. I think Jipkin also not required. We are using like a ELK stack that is not part of Spring Cloud. We will be use that stack also as part of here. And the config management, if anyone is depending completely on the Spring Cloud, then they will use like centralized configuration, Spring Cloud config server and config client. But in the real time, we will never use this one because we are using cloud specific configurations and secret management there. So out of here, we will be use Eureka server, cloud in load balancer, open fiend client, resiliency 4j, cloud gateway, ELK, all the these technologies we will be discuss as part of in our architecture here, guys. Clear about the components? Clear?
Yes, sir.
Yes.
Okay. These are the components of the Spring Cloud Netflix here, guys. So from
Sir,
yeah,
sir, what is can you just give more detail about circuit breaker? Like,
sorry.
there is one feature, circuit breaker
Okay.
history.
Means
Like,
if you have a service 1, you have a service 2, you have a service 3, service 4. Now you are making a request. This request is depending on here, and this is depending on here, this is depending on here. If this service is down, usually what output you will get? Internal server error, 500 exception, correct?
yes.
To
Okay.
avoid, I mean, even though
Mm.
service is down, we will implement one pattern, circuit breaker pattern. How it will be? That is called resiliency. I don't want to make 500. I want to make 200 by providing some successful response, some catchy response. For some time, few minutes, I can give some other response. Like that, we can handle our architecture style. For that purpose, we will use circuit breaker pattern. High level. Anyway,
Mm.
in detail level, we will be discussed as part of our project
Yes.
as well also. Clear?
Okay. Yes, sir. Please.
Super
Sir,
awesome.
just a one question.
Yeah,
We make each API like user API, product API, right?
correct.
So that is one microservice. Product API is one microservices,
Mm.
and user API is one
One
microservice.
microservice, correct. Now, if you see, user service is one microservice, product service is one microservice. Now, if you going to again this architectural style, what is our architectural diagram? Now we need to start about the cart MS. Now,
Okay.
slowly it will start communication. Why? Because cart microservice is depending on another two services, correct or not? Am I
Yes,
correct
sir.
or not? Cart. Why?
Yes, yes.
Because without user, you cannot add a product to the cart. Without
Yes.
product, you cannot add. So obviously, another microservice is depending on these two functionalities here. Here, like a REST template, how you can communicate through without REST template with Fiend client, how you can communicate slowly, all patterns will come to the picture here. Clear?
Oh, yes, sir.
Sir,
Yeah, others.
sir, which design pattern we use our project?
Which design pattern? It's not like a single pattern. Multiple patterns will be there internally.
That means in microservices, different like Saga pattern or
That is completely transaction management, CQRS and Saga. That is completely different.
okay.
Apart from those two, other patterns like circuit breaker, service discovery pattern, API gateway, these are all the patterns. That is transaction management, completely different flow. That is we are not taking care in our architecture style. Why? Because that CQRS and Saga itself, it will take 20-25 days of time. That is completely advanced pattern.
Yes,
Got
sir.
it?
Means suppose interviewer ask which design pattern
Yes.
follow. So
Yeah. For our understanding, especially for interview level, also, I will share you how to prepare those questions and answers as well. Don't worry. Okay. Even though we are not implementing, but we should be aware what CQRS it will do, what Saga it will do. You should be aware those patterns also here. Okay. By end of the course, I will be share you those videos also to you, preparing for interview level also. Okay. Got it?
Yes, sir.
Okay. Yeah. So for today, I am closing the session. Tomorrow we'll start from the cart microservice functionalities, guys. Cart MS. Yes.
Very, there is one question regarding yesterday's lecture.
Mm-hmm.
Actually, in my case,
Mm-hmm.
there are multiple tables.
Okay.
So in JPA, how would we connect, like join that
I said
10,
right.
50?
Till now we approached only two use cases. Third one we are not yet discussed.
Okay.
One
So it will come
pre
later.
yes,
Okay.
yes. Predefined methods is one approach. Then
Yes.
DSL is the second approach. Third,
Yes.
using query. Have you gone through my document, Spring Data JPA?
No, sir, I have to.
Please, please
Um,
read the notes.
that.
Everyone, it is mandatory. You should read our notes as well. Notes is very, very important. Like, let me show you where it is there if you not aware.
Yes, sir.
Um, See, in our workspace, we created one folder called notes folder. Here, three
Okay.
documents we have: data JPA, RESTful services, Spring Boot notes. Day to day, you should go through. Once small topic is completed, just visit these notes and read the document. Got it?
Okay, sir. Thank you, sir.
Detailed information in this PDF notes is there apart from our presentation. PPT is for our presentation purpose we are using. We cannot share the PPT. So that's why we are giving the notes to you. Complete information will be there, guys. You no need to go for again Google and no need to read. Everything is given here. See here, JPA annotations, database connection properties, schema generation, and DSL. How many of you gone through? Even I don't know. Lot of things are there in these notes also, guys. What are the development steps is required? Got it?
Great, sir. Thank you.
Okay. Yeah. And the same way REST APIs also. Still, middle of few
No,
topics are
sir.
pending. Yes. Yes, Pranav.
Sir, my question is we are using the ER diagram. No, sir, we are using the ER diagram for our project.
PR diagram right now. No.
One to many relational mapping.
Right now, yesterday we used one-to-one mapping, correct?
Yes, sir.
Now, when we discuss about another service, another mapping, we will be do that. One to many, many to one, like that.
Okay.
Okay.
Sir, and tomorrow when we start the cart, sir, one question. When we start the new API service, then in the primary, can we use the alphanumeric value? Because if we
Already,
use 1, 2,
already
3
we
as a
give,
at the rate of I,
already I
okay,
given one video. If you gone through or not, I'm not sure. Primary key generation, right? With alphanumeric. Those videos are available in our
okay.
YouTube. Just
Sir,
you
I'm
can
not good.
visit.
I will see that. Okay, sir.
Sure,
And
sure.
for alphanumeric value, I'm
Yeah,
saying.
yeah, yeah. Alphanumeric
Yes.
only. You can do that. Let me show you. See, few topics I may not explain in the classroom, but those videos available in our YouTube, you can watch it. Okay. That's why I'm covering complete use cases.
Okay.
In the YouTube also you can learn. In our classroom itself also you can learn. Classroom videos you may not available in the YouTube. YouTube videos may not available in your classroom. Got it? Why? Because training will be completely different in the YouTube also,
Okay.
right? Let me show you. It may useful for you guys also. If you visit our channel. And guys, I'm giving one link to you. Everyone, please join in this Facebook group, guys. We started now communication to here as well. Let me share now. Just I given a link. Just visit our Facebook. Just join Java Express official. Here, just you can join, guys. Okay. And as I said, go to the playlist.
So you can create in LinkedIn as well. This
Yeah.
feature.
LinkedIn also we have. Slowly we'll
If
start in
someone is
social
not
media.
using,
Correct.
actually Facebook
Okay,
is
sir,
not being used
please
that
give the link of alphanumeric value also.
That's what I'm showing right now. There is a Spring Boot miscellaneous videos will be there. Somewhere should be there. Spring Boot microservices, real time. mm, just a minute. Yeah, Spring Boot miscellaneous videos here you have. Here, audit logging, how to handle in Spring Boot. And there is, yeah, primary key custom generator, alphanumeric. This you can watch this video. Okay. And Fiend client, deploy your application into AWS. This is some kind of videos may not teach you in the classroom. These you can watch from your
Because
end.
sir, in the real time
Yeah, that's why I'm saying that here I'm covering here. You can watch the video. Okay. Yeah. Pagination we will be discussing. Don't worry, guys. I given Excel document to everyone, right? As per Excel document, by end of the course, we'll cover everything. Don't worry. Okay. Got it? Admit to notes repository. You need to send an email. Just if you send an email, we will give access to you, Mircha, if you are a new joining. Okay. Any questions before closing? This miscellaneous video link also will be share you in the group. Just you can visit whichever video is required. Just you can go ahead and watch. Okay. Chalo then, thank you guys, and we'll start new microservice from tomorrow onwards. Don't miss classes, and please join sharp at 9 o'clock. Don't join 9:1, 9:2, 9:3, 9:5, 9:10. People are joining randomly. Sharp at 9 o'clock. We'll start immediately our session, guys. Okay. Chalo then, thank you.